Hello and welcome to a new video where we try to learn electronics. This time I have a helper. My son Jonas is here. His hands will be appearing shortly. There they are. Say
Hello.
hi. Hi.
Hello.
Last time we put together I tested the setup and it all seemed to work pretty well. And actually, before I get into that, I should note I have a nice mat now, which I think deadens some of the sound a bit, but also it's an anti-static mat, so that's nice. Yeah, so let's get going. I don't have a big plan for this one. Last time we hooked up a button and made the light up, so I thought maybe we should make the light up when you're not pushing the button, right? Like a logical inversion. So I have this kit of lots of 74LS chips, which are like logic gates and things like that. And so we're going to use, I think, a hex inverter and see if we can do this with a hex inverter, because an inverter does the logical opposite, right? You feed it in like a truth value and it returns a false value. And so we'll pick out SN74LS04 and try and hook it up and see what happens. Okay, I think I got the right one. There we go. Yep. Is that right?
SN74LSO4N.
All right, that's the one we're going to try anyway. Okay, let's pick a spot. Where should we put it on the board here? Let's do...
Well, first we probably want the button.
Nah, we don't need that yet. Let's put this on first.
Here?
Yeah, okay. So the way these work, if you don't know, is this part here is like a gap, right? There's no connection across this way. All of these things are called rows, but they're only connected from here, like these four. Wait, that's five. I can count. These five are connected. These five are connected. These five are connected. So there's no connection between here and here, for example. So the connection electrically is these five lines are connected. These five lines are connected. These ones over here are not connected to this side, right? So these are all connected, and these are connected, and these are connected. And these on the side here, I think they're usually called like the power rails, and they're connected in the opposite direction. So horizontally in this case. So this one, this, and this, and this are all connected. Now this is also different because all of these groups are connected. So this whole row, I guess, is meant to be hooked to plus, right? It's not actually plus until you hook it to plus, and then this one is for minus power, and then this is the same. Now, like this side and this side are not connected. If you want them to be, you're going to have to run wires to connect them. So the purpose of this gap, of course, is so you can do things like this. You know, put the chip in here, and you know, now each of these pins, you can connect things to them without them affecting each other, right? Now, what I know of chips, for example, the chips often have these little gaps and dots on them. This is like the top of the chip. I don't know if that's the official name for it, but like it's an orientation point, and then the dot, the indent, is on pin number 1. So when you look up information about chips, like for which pin does what, that's how you figure it out. Yeah, so in this case, on our little box here, we could look up a data sheet, but we're going to use this one, and it tells us, you know, here's the orientation thing, and then there's a dot here, right?
Yeah, 1.
So that one's 1A, 1Y, 2A, 2Y,
3A, 3Y,
right?
Ground.
So here's ground. What's VCC? Do you know what that one is?
No.
This is our, I don't actually know what the CC stands for, and I should look that up at some point, but VCC is like plus 5 volts. That's where our voltage goes in. And then ground is where the ground goes. So the chip itself has to have power before it can do anything. So that's step 1, I think. We'll hook up the power to the chip. So let's see here. In order to do that, we need some wires. Do you want to grab the wires?
Okay. So we want some of these.
So according to this...
So long ones?
this pin here, which would be 1, 2, 3, 4, 5, 6, 7,
here
is ground. And I don't know if that comes through on the camera very well.
Right
this
here.
one, yep, 1, 2, 3, 4, 5, 6, 7 is ground. Now I think we don't need a long wire like that, just a really short one. And let's go over to the minus. Yeah, that'll work, I think.
Hard to grab.
They are hard to grab.
Even with these tools.
I'll just use my fingers. Okay.
Especially when you
we'll
don't
hook
push
this
it in all the
one
way.
to ground like this.
Yeah.
Okay.
That
So that should be the ground pin. Now, according to this, VCC is up and on this side, right? So it's this top one here. So we need to hook that to the red power. So we need another wire.
This one should work.
These are so hard to hold. Okay. So this one, oh my goodness. Yeah, red to there.
That should be connected.
Okay, now we're powered up. Now, of course, obviously, this isn't going to do anything interesting. Not yet, anyway. So let's put an LED on here, of course. We're going to want one of those so we can see something. So now we have to pick a gate to use. These things are called gates. The inverters, there's a whole bunch of them on here, and I think the reason they call it a hex inverter is because there are 8 of them. There's not 8 of them. There are 6 of them. So I don't actually know why they call it a hex inverter. In any case, I know that 1A and 1Y are connected, and I know that from looking up stuff in the past. So 1A, 1Y, A is the input, Y is the output. And this is gate number 2, and this is gate number 3, and 4, and 5, and 6.
It can do
So it can do at least 6 of them.
Yeah, it can do
right
at once.
So if you had 6 things you needed to invert, you could just get away with this one chip.
I'm gonna Okay, I was thinking because this is different. It might have less or more gates.
Yeah, it's the same, isn't it?
Yeah, it's the same.
Yeah. So we know that from the pinout that this is an input and this is an output for the first gate. So we want positive to be true, right? That's usually the case anyway, as far as I know. So that means that there will be positive on this when we want this to light up. I think what that means is we need to kind of make a little bit of a jumper situation. The longer one is positive. That's the anode. And I'm just going to put this here. And so then what we need is a jumper from here to the output of the first gate.
So that shouldn't be a long while.
Not too long, nope.
I think we can get away
Yellow or
with one of these.
a blue maybe?
But this is what I'm talking about.
Okay, here we go. Let's put this here. And oh, that is almost perfect. I'll just angle it a little bit.
A bit too long?
There. So that gets us part of the way. And as we talked about in the last video, you need a current limiting resistor on an LED. As far as I know, I believe some of these chips have them built in, but I don't actually know if this one does. We're just going to go with this for now. This is going to be the positive side, so this is the minus side. So we hook that to minus. Okay, now we have not fed any input into the other side of this gate here, so
a button.
I think let's get it to work first. Yeah, can you grab one of those long,
this,
like pinned, this thing, like this. Here we go, like this thing. I don't even know what this is called. Jumper, I guess. Long pin jumper, maybe. So what we'll do is we'll put this in here. This is the input to gate 1. And to start with, we will make it true. So we'll put it to plus.
Now we need power.
Now, what would happen if you set a true into an inverter?
It'll become a false.
Becomes a false. And false is how many volts? 0? Or
Zero,
it's ground.
I think it's 0.
Ground. So that means ground would be connected here. And this side connects to ground. That means both sides are ground. So this should not light up. Let's test that.
Yes.
Uh-oh. We need batteries, don't we?
Well, have
go.
some over here.
All right, here. I'll zoom out. Put some batteries in there.
Almost put one in the wrong way. That would be bad.
Okay, so I think what this will do is I think we'll hook it up and nothing will happen, which, you know, in this case is actually probably exactly what we want. All right, do you want to plug it in? We're using the plus on this side, and then we're using the minus on the other side. Oh wait, I have something hooked into minus here too. Okay, that means we have to plug in, we have to connect these sides because we did this. So we need a long jumper that can go between this minus and this minus. Well, you can use one of those colored ones if you want, or
this blue one.
Okay, we'll use that one.
We'll make it so we have some color coding.
Yeah, that's okay. We can just untwist that if you want.
Yeah, that would be good.
Yeah, this is only this way because we've never used them before. Oh boy, that's going to be a mess. Okay,
let's just
blue one.
Ignore that.
Okay,
so
hook the two blue rails together. Yeah,
should be
minus to minus, because we didn't use the positive side on this side.
Negative to negative. Then we just connect them up like this.
Yep, you can do that.
It does not light up.
It did not light up, which is expected. Now let's send it a false signal. Oh, it didn't light up. What did we do wrong?
We have some tools that we can use to figure out.
Well, maybe. Wait a second. What's wrong with this one? Hang on, now it's working.
Okay.
Was it just not in all the way?
I think so. Okay, we got it correct.
I can see how that's a difficulty with the breadboards, these wiggly connections. Look at that. Yeah. Maybe this is not a very good breadboard. Or maybe this is not a very good wire.
For breadboard.
This may lead us astray.
But we can always use our tools to figure this out.
Oh, maybe it's the power. It was the power one, maybe. Huh. Yeah, there's definitely bad connections on here. Maybe we should get a different breadboard. That's better. That's more stable.
I'm gonna move this around so we don't get all tangled.
So it's not tangled up.
Yeah.
Okay, clearly it's very loose over here, and I wonder what's to blame. This wire fits pretty tightly there. Is it this jumper, maybe? Let's try a different jumper. Let's try this black one. Oh, look at that.
Well, it is small.
It was that wire.
It is. This is small. So.
Yeah, I don't think that matters though. That must have had a bad connection on it.
Maybe we should get rid of this.
Yeet it.
Yeah.
Yeet it. Yeet. Okay, that's what the kids say these days. I've been assured they say things like yeet. Okay. Now let's do what we were gonna do. Let's add our button.
We probably want to.
And so that it's inverted. So let's just, what should we do? Plunk it down. I think we can put it pretty much anywhere.
Yeah, that's good.
So we switch this to like this. And then we need...
for single.
I'm just going to use this. I think like, it depends how this switch goes to this side. All right, let's add some power and see if anything explodes.
Hopefully nothing does explode.
Okay, nothing's exploded so far.
But no power. Okay, negative. Positive.
Okay. So maybe this is connected wrong, right?
Yeah. We want it to be active. Okay. So, let's think this. Okay. So, when it's pressed, we want power going through here. Is that right? And that's negative. And that negative goes to the light.
I wonder if this switch is like turned around. Should we use this thing?
Yeah.
Use the multimeter. So, okay. Putting on continuity mode, that means that it detects if the connections are, you know, connected. All right, push the button for me. Wait a second. That's already continuity. Wait a minute. What's going on here?
It's transferring through the button. Is that button just bad now?
Well, you know what? Maybe we had to turn 90 degrees. What's going on here? Okay, now try it. There we go. It was rotated the wrong way. and because these are connected, yeah. That makes sense in hindsight. Okay. So that means this to this. And then this goes to positive, I think.
So when
No, that didn't do what I thought at all. Wait, is the power hooked up? Yeah, it is.
Okay, so let's
What are we doing wrong here? Oh,
both of these will be connected.
my brain got flipped around again. Yeah, look at this. They don't connect like this. They connect like this.
I was thinking different.
Okay. But it's still not working.
So, when you
wait, that's the opposite of what we wanted. This is pushing the button and turns on. That's because this is going to low. We don't want it to connect that way. We wanted it to be so... Wait, we wanted it to always be on, and it's not on. Yeah. That's the problem, right? It should be on now. Okay, so I think the problem is that when this button is not being pushed...
There's no power.
There's no power at all, and so I think that our input is doing what's called floating, as in it doesn't have any... It's not true or false. Right, it's somewhere in the middle, and that's confusing it. So I think what we have to do is we need a resistor to pull it down or up, one way or the other. And we have a bunch of resistors here, and I don't know how big the resistor should be. I'm sure it matters, but I don't know. I think you would use a high one because you don't want it to use a lot of power. I don't know if that's correct or not. This is 100K. Is that too big? I don't know. Let's use 100K. I have no idea. It's possible that this is all wrong, and because, you know, I wasn't super well prepared for this. Okay, so I think that you put this here, and what we wanted was we want it to be false by default, right?
No, we want it to be... Wait, this side false. We want this side to be false.
We want the input to be false by default.
The false
I don't
side.
think that did what I thought it was going to do.
Positive. This is false.
Is this in the wrong one?
We might want to move that to positive. For the light, we want this to be... There's this negative one.
Maybe this is too big.
And it needs to be a positive one.
Oh, do we still have power? Yeah, we do.
Wait.
So we wanted it to be on until you push the button, right?
Is that... Okay, let me just...
So that means, what happens if we put this...
See something. So that's pin 1.
Yes.
Yes. So that's... Let me use this as a pointer. That means the one right below it, that one is the output, I think, because it's Y.
Well, we already had that part working. Maybe this one's too
big.
And
then this is the power. VCC, so power. Then here's the ground. So ground, power, 1, 2.
Yeah.
So we want this to be output. Which makes sense.
There. Okay.
Okay.
Now it's being pulled down.
And then the input.
And if we hook this one up, this is the input. It's the same pin. But now if we go to positive, it overrides it. That's what I wanted to do. So now do we hook it up to the switch? There. Now it's inverted. Okay.
Yeah, and when you hold it, it walks.
Okay, we did it. We succeeded in inverting something, I'm sure badly. I don't know how you choose values for these resistors. I haven't really worked that out yet. Obviously, this one was obviously too big, because I'm assuming that means not enough current flowed at all for the light to go. Okay, we made an inverter. An inverted inverter. Well, not really, but we kind of did, right? It's on by default. You push the button, it turns off. That's probably useful. All right, I guess that's it for this video. We got this to work. Jonas was our helper. And I guess we say goodbye. Goodbye.
Goodbye.
I get thirsty. Yeah.